In section 3.6, we'll be using the quadratic formula to solve quadratic equations. We'll also discover the discriminant here in just a little bit. Most of you guys should be familiar with the quadratic formula. You've seen it before. A, B, and C come from our standard form. A is always in front of x squared. B is the coefficient of the x term, and C is the constant all by itself. What is nice is the quadratic formula can be used to solve any quadratic function once it's in this form equal to 0. It's just sometimes there's easier methods such as factoring or getting x by itself and square rooting that could be a little bit faster or smooth to use, but this is a nice one because it always works. Okay. As far as deriving and where it comes from, I'll explain that in class and we'll see how that all works out. Let's dive into a problem. Here are the steps. So we want to make sure it's in standard form, make sure it's equal to 0. Make sure you know what your A, B, and C are. Watch your signs. You plug them in and you got to simplify it. We don't want to see decimals unless they ask for it. Otherwise, we'll leave it as a simplified square root or fraction. So notice this first one here, we need to first move the 5 over, get it equal to 0. Feel free to put little labels in here. There's a 1 right here, so we have an A value that is 1, B is 3, and C is -5. Notice when we're plugging it in, I'm not plugging in any of the x's or x squareds. I'm taking the coefficients, the 1, the 3, the -5. We're just taking those numbers and plugging them in. You can put all this in the calculator, but it usually runs into issues. My advice would be to simplify it. So notice on this next step here, I left -3 alone. 2 times 1 is just 2. I want to figure out what this is. So instead of typing all of this into the calculator, I just did 3 squared minus 4 times 1 times -5. I want to see what these turn into. When you combine all those numbers, you get 29. If you then try to square root 29, you're going to get a decimal that's kind of irrational, can't really simplify it easily. We'd have to round it. So actually, we could stop right here. That would be our precise answer. And if we need to, we can get decimals. By the way, I'm totally fine stopping here. Sometimes textbooks or programs have you split it up. There's the plus square root of 29 as one option or the minus square root of 29 as the other option. I don't care if you do that. It's just usually simpler, just write it as one answer, but there you go. And if they do ask for the decimal, just take your two options. Take -3 plus the square root of 29, get that answer, and divide it by 2. You're just kind of an awkward decimal. Same thing here, just subtract the square root of 29 and divide by 2 to get that answer. Feel free to pause and try these other ones out. Otherwise, I'm just going to go through them. This one's already equal to 0, so I'm just plugging everything in. Notice it's -b. My b is already negative, so this becomes a +6. I just start to simplify. The 6 stays the same. 2 times 1 is 2. This here all turns into a 20. You can't square root 20, but you can break it down. So if you use something like 4 and 5, you can square root the 4 to get a 2 and leave the 5 inside the square root. Notice here now we have a 6 and 2 that can both be divided by 2. This is all one term. I don't want to take the 2 into the 5, but I can take the 2 to the outside number. So if you divide by 2, 6 divided by 2 is 3, and 2 divided by 2 leaves 1 or just the square root of 5. And there's your simplified answer. All right, let's see. Let's move 2 things over here. So we're going to minus the 12x to get -20x. We're going to add the 4, and then we could just go ahead and dive into our quadratic formula. Plug these all in, get some bigger numbers, and that happens. When you combine all these numbers, you get 0. So actually the square root of 0 is just 0. So really what we're left with here is just 20 over 50. Because you add or subtract 0, it doesn't really change anything. So 20 over 50 just reduces to 2 over 5. Which, since we actually have kind of a nicer answer, that no square root or imaginary answer, we actually tell us we could have factored this. It just might have been a little bit more challenging with the 25 here, but feel free to go back and try it yourself. All right, again, get it equal to 0. We just have a -1 for our A here. So I'm just going to plug everything in. When I go to simplify, these numbers combine to get -36. I can't square root a negative because that's going to be I. I can square root 36 to get 6. So how about we simplify this down to plus or minus 6i. Notice both of these could be divided by -2. -4 divided by -2 gives you +2. Since we have the plus and minus, it really just stays plus and minus. And 6 divided by 2 makes it a 3i. Over here again, move all your things to get it equal to 0. Plug in all your values into your formulas. I hope you guys have been pausing as needed to write things down. And just simplify. Everything inside the square root here turns into -108, so another imaginary situation. 108 you can't square root, but you can break it down. I chose to use 36 times 3. I can square root the 36 to be just a 6i, since we're doing a square root of a negative, and leave the 3 inside. And notice the -2, the 6, and the 14, I can't divide all of them, by 14, but what I can do is divide everything by 2 and simplify it. So if you divide by a -2, to kind of just change some signs, -2 divided by -2 is 1. The 6 divided by -2 just remains plus or minus 3 now. And then 14 divided by -2 is a positive 7. The other side of this is also the discriminant. Just to show you that, is the idea here is the part underneath the square root, the b squared minus 4ac, it tells you about the nature of your answers, okay? So if we look at this part here and that number is bigger than 0, then you're gonna basically cross the x-axis twice and there's 2 real answers because you get square rooted. Now, if it's a perfect square, that's even better. That means there's 2 rational answers. They'll be very nice numbers. If it's something you can't square root, it's not a perfect square, then they'll be irrational, kind of like what we saw over here. We had the square root of where'd it go? Sorry, back another page. We had the square root of 29. We can square root it. It's just going to be an irrational number. Here again, an irrational number for these guys here. Okay. If the b squared minus 4ac, if you just do that part and get 0, it tells us that they'll hit the x-axis just 1 time. So there's only 1 real rational root, 1 real answer. And if that b squared minus 4ac is less than 0, then, well, then you're going to not cross at all, which means we have imaginary answers. You'd have a negative number. You can't square root negatives, so it's imaginary answers, or what we call 2 complex roots. No real roots. So if you try that out, let's just find out our discriminant because we just want to figure out the number of answers, the number of roots or solutions. So here we go. Notice these are already equal to 0. I'm just doing the b squared minus 4ac. I'm not doing the full quadratic formula. This will just tell me about my answer. When I plug those numbers in, what I get is 44. Now, we can square root 44. It's going to be like not the prettiest of answers, but you can square root it and get a decimal. So it tells me there are 2 real answers. They're just going to be irrational roots. So like some sort of a decimal answer. You know, square root of 44 or not square nicely. Let's see, over here, if we do it, plug in all your numbers, you actually get 0. Well, you can't square root 0 and get 0. There's only 1 real rational root, 1 answer. Try this one out. We plug in all our numbers. We get 144. That's something we can square root. It's a positive number, so we definitely have 2 real answers. And you get square root 144 nicely. So how about 2 rational roots? It'll be actually like a nice answer, like a whole number or maybe a nice fraction. This one, we plug everything in and then you simplify. The b squared minus 4ac gives you negative 124. Well, we can't square root negative, so right away I know this is going to be 2 imaginary answers, or what I call complex roots. And we can also apply it to a situation here. So she wants to serve this ball here, and it's given by this formula. We want to see, like, can it reach a height of 4 meters? So we don't actually define, like, the time. We just want to see, hey, is this possible? So let's plug in 4 for the height. So we're going to plug that in here. I'm going to get it equal to 0 by minusing the 4 and combining it with this. And then instead of doing the entire quadratic formula to solve for the actual time, I'll just see, is it possible? Let's just do the discriminant, the b squared minus 4ac, because they're just asking, is it ever possible? What you do is you get negative 15 when you simplify that. I can't square root negative, so there's no real solution to that, which means this is not possible to get to a height of 4 meters.